Hi there, this is Mrs. Often, and I'm just taking some time right now to review the Unit 2 calendar, and this is our second unit of geometry. It's the third unit we'll study, and it's the third chapter in our reference textbook, Holt Geometry. So I just want to go through the calendar, and I also want to take some time right now to talk about what you should be able to know and do when you finish this unit. By the time you finish this unit, you will be able to prove a number of theorems related to parallel lines and special angles formed by parallel lines. You will know and be able to use all of the definitions, theorems, and postulates that are in Chapter 3 in the Holt Geometry textbook, including parallel lines, skew lines, perpendicular lines, and working with slopes of lines and the equations of lines. You will be able to, based upon information given in a diagram, determine if lines are parallel and why. You'll be able to write a proof of this. And you'll also be able to use algebra that may involve systems of linear equations or single variable linear or quadratic equations in the solution of many problems, such as determining the value of x that makes two lines parallel, determining the slope of a line given 2 points, finding the coordinate value that will make two lines parallel or perpendicular, writing the equation of the perpendicular bisector of a segment, writing the equation of a line in various forms, including standard form, slope-intercept form, and point-slope form, identifying the slope and y-intercept of a line when the equation is given in a variety of forms, determine if two lines are parallel, perpendicular, intersecting but not perpendicular, or coinciding, graph a line, and solve word problems dealing with equations of lines. So let's scroll back up and see exactly where this journey will take us. We've already taken our quiz on matrices, and those grades are in Aspen. Starting on October 13th, we'll do work with proving theorems related to special angle pairs. We'll have an in-class jigsaw activity, and there'll be problems using algebra to determine angle measures and using an auxiliary line in the solution of problems. On Friday, the 14th, we'll work to prove that lines are parallel given characteristics of special angle pairs, and you'll use algebra to determine the values which make two lines parallel. We'll have an in-class activity of some note-taking and a card sort. When we return after the weekend, students will determine equations of parallel and perpendicular lines in the coordinate plane, finding values of variables which make two lines parallel or perpendicular. We'll have a MathLib activity that will review parallel and perpendicular lines. And the following day, we'll work to determine the shortest distance between a given point and a line, and we'll use some properties of parallel lines to prove that the sum of interior angles of a triangle is equal to 180 degrees. We'll have a day for review, and then we're planning to take the test on October 24th. I look forward to working with you as we study parallel lines, special angles, perpendicular lines, and their equations.